Gate valves are primarily used for turning fluid flow on and off and for isolating equipment. They're normally installed in applications where straight flow is desired. A gate valve generally has a relatively long body and stem, which extend some distance beyond the piping that the valve is connected to. A gate valve typically has two seating surfaces and a disc that fits between them. The disc is raised and lowered, like a gate, to start or stop the flow of fluid through the valve. This valve has a wedge-shaped disc. When the closing point is reached, the disc is wedged tightly against the valve's seating surfaces and flow is shut off. Sometimes a wedge-shaped disc is split down the center and the two halves rest independently on opposite sides of the valve seat. Small gate valves generally have fixed seats that are cast as part of the valve body. It's more economical just to replace these valves than to repair them when they're worn or damaged. Large gate valves, however, frequently have replaceable seats. With these types of valves, it's less expensive to replace the seat than the entire valve. Many gate valves have what is called a rising stem. In most cases, the stem rises as the hand wheel is turned counterclockwise and lowers when the hand wheel is turned clockwise. The amount of stem protruding from the hand wheel indicates the position of the disc. If the stem is all the way down, the valve is closed. If the stem is all the way up, the valve is open. On a gate valve with a non-rising stem, the stem and hand wheel rotate together. The disc is threaded to the lower portion of the stem. The disc then moves up or down the stem as the hand wheel is rotated, but the stem does not move up or down. Because no allowances for stem movement are necessary, a non-rising stem is useful in applications where space is limited. Gate valves work best when they operate in either the fully open or the fully closed position. When a gate valve's disc is completely raised, fluid flows straight through the valve with little obstruction. However, if the disc is partially raised, a space opens on either side of the disc and fluid passes under the disc. This type of flow creates turbulence and causes the disc to swing from side to side, banging or chattering against the seating area. The chattering quickly leads to wear on the seat and the disc. Eventually, the damaged valve won't be able to shut off flow even when it's fully closed. Also, the flow of fluid through a partially open gate valve wears the disc unevenly. In time, the edges of the disc that are most exposed to the flow become eroded, and the disc can no longer seat properly.